Hey, thanks for choosing Student Phase Smart Lecturing. In this video, you would be learning about common base configuration of a transistor and its input-output characteristics. The figure shows common base configuration of PNP transistor. Input is applied between emitter and base, whereas output is taken from collector and base. Base is common to both input and output. Hence, the name common base configuration. VEE and VCC are variable voltage sources. The voltage readings are recorded using voltmeters VEB and VCB between emitter base and collector base, respectively, as shown in the figure. Current readings of emitter current and collector current are recorded using milliammeters, as shown here. So, this is a basic setup of transistor and common base configuration. Now let's move on to the input characteristics of CB configuration. And to obtain this, there are certain procedures. Alter collector supply voltage VCC to set collector base voltage VCB to a fixed value, say 1 volts or 10 volts. Now, increase emitter current, i.e., in small values, say 1 milliamp, and record values of emitter base voltage VEB. Continue increasing IE till you get sufficient readings. Once you get sufficient readings, change value of collector base voltage VCB, and repeat the above steps, 1 and 2. Plot a graph of IE versus VEB, keeping VCB constant. The plotted graph may look something like this. Based on the observations, we can arrive at certain input characteristics. Input resistance is calculated as the ratio of change in emitter base voltage VEB to the resulting change in emitter current, i.e., at constant collector base voltage VCB. After emitter base voltage VEB exceeds 0.7 volts for silicon and 0.3 volts for germanium, the transistor starts conducting. This is called barrier potential. And this is that region where VEB exceeds 0.7 volts and starts conducting. After barrier potential, small change in VEB results in large change of IE. This means VEB has changed very little here, but IE has increased drastically. Therefore, we can say that input resistance is very small. Here, you can also observe that there is little increase in IE with increase in VCB. VCB is positive for NPN and negative for PNP transistors. VEB is negative for NPN and positive for PNP transistors. Now let's move on to the output characteristics of CB configuration. And to obtain this, there are certain procedures. Alter emitter supply voltage VEE to set emitter current, i.e., at a fixed value, say 5 milliamp or 10 milliamp. Now, increase collector base voltage VCB in small values, say 2 volts, and record the measure of collector current, IC. Continue increasing VCB till you get sufficient readings. Once you get sufficient readings, change value of emitter current, IE, and repeat steps 1 and 2. Plot a graph of IC versus VCB, keeping constant IE. The plotted graph may look something like this. Based on the observations, we can arrive at certain output characteristics. In active region, emitter base is forward biased, and collector base is reverse biased. From the graph, you can see that IC is approximately equal to IE, and here, the transistor works like an amplifier. Output resistance is calculated as the ratio of change in collector base voltage VCB to the resulting change in collector current IC at constant emitter current IE. It is very evident from the graph that there is very small increase in IC, with large increase in VCB. The value of IC here and the value of IC here is almost same. Therefore, output resistance is said to be very high. In saturation region, both emitter base and collector base junctions are forward biased. You can also see that collector current IC is independent of emitter current IE. Region below IE equals 0, which is this, is called cutoff region, and here, both the transistor junctions are said to be reverse biased. This concludes the video. Thanks for watching.